Welcome to the CAD Builder video tutorial series. This is an introductory video on CAD Builder's material optimization intended for trial or new users interested in material optimization. It picks up where the first intro video left off, utilizing pre-trial global options and default cabinets. Please keep in mind that the result will not likely match your shop specifications without you customizing your setup. CAD Builder can give you the most efficient material usage by nesting cabinet parts onto material sheets. But it must first know how to cut the cabinets as well as what to cut them from. So we will open the design from the last video and make sure that the global options have been assigned by clicking on the design options at the top of the design menu. When we're ready to extract our cut sheets, we go to the Cut List module through the main control panel. This is the staging point for the nesting process. The list of cabinets is shown on the left, with the constituent parts shown in the cut list on the right. The cabinet list has a checkbox next to each product. Excluding a cabinet with this checkbox removes all the product's parts from the cut list table as well as from the subsequent nest. This can be useful when you want to prioritize certain cabinets over others. For example, if you need just the wall cabinets cut first, then uncheck all the other cabinets from the left. Or you can click on the filter button at the top of the list and select Show Wall Cabinets. The cut list table will then only show wall cabinet parts for nesting purposes. Or if you have multiple rooms in your design, then you can check other rooms off before moving forward. You may also exclude individual parts by utilizing the Optimizer column in the table. Unchecking a part in that column excludes it from the subsequent nesting, or you can click on the triangular icon next to the column name and uncheck part types. This will uncheck all the entries in the cut list that match that part type. So for example, if you want to cut all the cabinet parts except for toe kick boxes, then uncheck the toe parts from this list and they will be excluded. Once the cut list table is ready, click Configure and Optimize. If for some reason this button is grayed out, then you either aren't using a license with Material Optimization or you haven't assigned the materials in Global Options. The optimization menu that appears will show different parameters based on your license type. If you are using the non-CNC version, then you will have two columns. On the left, you can filter out materials from the nesting process by unchecking their boxes. For instance, you probably won't need to see sheet nests for hardwoods, so unchecking them here removes all associated parts from the process. Below this is the remnants section that allows you to utilize partial sheets left over from previous cuts before moving on to full-size sheets. The top of the right column is where you choose what part label templates to use for each cabinet part, as well as the remnants. We will cover details on the labels in future videos, so for now we will use the defaults. Optimization quality controls how many nesting algorithms are used when determining the most efficient layouts. We recommend keeping this at best for the most possibilities. Part spacing should be set to the diameter of the saw blade used to cut out the parts. Then indicate whether or not to detect remnants as well as their minimal size and where to save them. For example, you might not want to save a remnant piece of 10 by 20, but a bigger waste piece of 15 by 35 can be used to at least cut a side, so you could set the minimum remnant width to 35 and height to 15. The trim amounts are the amount of material you shave away from the factory material edges, measured from the top, bottom, left, and right edges. The final options set how the nesting algorithm should work. You can set the first cut to either rip or crosscuts. If there is no preference, then you can set it to both for better material efficiency. If three-phase cuts are disabled, then nesting algorithms will prioritize placing parts in such a way as to minimize the amount of rip or crosscuts for each part. This means less time would be needed to rotate your sheets, but at the cost of material efficiency. Whereas if you enabled three-phase cuts, then nesting algorithms will allow for additional rotations for better material efficiency, but perhaps more cutting time. Switching to the CNC license version, we see a similar menu as before, except with an additional column responsible for picking the machine, tool set, and associated strategies and speeds. We will leave the machine and tool library setups for future videos, so for this video, we will just check optimization without generated G-codes. Click Optimize when ready, and CAD Builder will make the material optimization send you automatically to the next module called Optimizer. This section has 5 submodules: Layouts, Labels, Label Templates, G-codes, and Toolpaths, the last 2 of which are accessible only to CNC licenses. There is also a 6th button that acts as a shortcut back to the cut list module if you need to re-nest. We will begin with the Labels module. This menu is split into 3 columns: Materials and Number of Sheets on the left, the Sheet Layouts in the middle, and Label Attributes on the right. Every sheet gets a sheet layout where every part is assigned a part code and can have dimensions and edge-banded edges highlighted if preferred. Each part also generates a part label that can be seen on the right by selecting a cabinet part. The generated labels are customized in the Label Templates menu, but for this video, we will only look at how the sheet layouts can be changed. Click on the gear icon at the top right labeled Label Setup. The first 2 sections allow you to change the labels for this nesting job. Print Elements controls what will be printed, part and remnant labels for individual labels, and sheet layout for the sheet diagrams themselves. We will uncheck part and remnant labels for this video. Part and remnant codes generate the abbreviated codes for sheet diagrams. Variables that change from part to part are written within braces, whereas constants can be written outright. For example, if we will delete the part code and we'll start with an opening brace, after being pressed, CAD Builder shows a list of variables. Select part.name.acronym, and the bottom of the pop-up menu explains what it does and shows an example. Part name acronym variables will, for example, shorten Adjustable Shelf Board to code ABS. Double-click on the variable to fill it in and continue by typing a £. Then we will bring in a variable for the cabinet.last-word, which takes the last part of a cabinet's name, usually the cabinet counter. Next, we will move on to remnant codes. Remnants would benefit by just marking their dimensions for easy reference, so its code will be part.width variable followed by x and the part.height variable. The next part are the sheet layout options. Part dimensions toggles the individual part widths and heights recommended to be on for non-CNC users. Edge banded edge highlights part edges that are marked for edge banding. The highlighted colors are chosen in the next section under banding color. For example, we will set the interior color to blue by utilizing the color picker. Exterior we will set to red and drawer banding to yellow. The final parameter, print sheet label, titles each sheet with the sheet number and material. We recommend keeping this on. Click Save to lock in these changes. We should see the abbreviations change as well as edge-banded edges highlighted. When you're ready to print the sheet layouts, click on the print icon at the top right. Click Print to send it to a printer or Save to PDF to save it as a local file. Next, we will check the Label Templates submodule. It is here that you create the part labels used in optimization. There are enough details here to reserve for a future video, so suffice it to say that you can create any label size with a host of information variables to adapt to each part. The last menu to check in this video is Layout. Here you can extract job information. If you go to the top right and click on the Information button, you can view job-wide material usage statistics. Click on Print Report to print this information and get a more accurate estimate of how many sheets you need for the design. The Layout menu also allows you to manage the cutting if any parts are defective. For example, click on Select Sheet at the top right of the first sheet and click on Mark Sheet Done at the top right. This marks the sheet as cut. Suppose that one of the parts from this sheet were cut incorrectly and must be recut. You can select it and click Mark as Defective at the top right to put in the Unplaced Parts bin on the left. This allows you to click Reoptimize at the bottom left of the screen. Doing so will re-nest everything that has not been cut yet, in addition to the parts in the bin, giving you a new, most optimal material usage. When the job is done cutting, click Job Done at the top left of the middle column to mark all sheets as cut. Remnants will then be saved to be used for future cuts before moving to full-size sheets. In your shop, you would shelf these remnants to be used when CADbuilder calls for them in future nests. By providing customizable part labels, sheet layouts, and utilities to manage the cuts, CADbuilder has provided a very efficient way to optimize material usage for each job in your shop. In our next trial video, we will check how to use G-code generation and label template creation. Thank you for watching. To view additional video tutorials, please visit www.cadbuildersoftware.com/training.